So today we're going to take all of our expressions work. We've written expressions, we've simplified expressions, and we're going to apply them to some geometric shapes and finding perimeter and area in some different situations. But before we jump into that, I want to take a quick look at some of the work we've been doing and see, can we answer a question that's maybe worded a little differently or presented differently, but still pertains exactly to the skills that we've been practicing. So if you take a look at number 1, it says if a equals 7x plus 4 and b equals 7x minus 2, what's the value of a plus b in simplest form? So it's a really confusing way to ask an easy question. So what they're really asking you, find the question. What is the value of a plus b? Okay, so we have a plus b. Now what does a represent? What does b represent? Well, they told you. A equals this. So if I replaced a, it's 7x plus 4. Plus b, and b is 7x minus 2. So this is what they're asking me. A plus b, here's the values, plug them in. What's the answer in simplest form? So all I have to do now is take this expression and simplify it. So that should be pretty easy to do. Combine your x's, that's 14x, and combine your whole numbers. It's a 4 and a negative 2 or a minus 2, so that's a positive 2 plus 2. Okay, so let's look at number 2. If a equals this and b equals this, what's the value? Here's the question that you need to answer. What's the value of a minus b? So it's a minus b. This is what we need to solve. We need to plug in the values, which are expressions in this case, and then simplify, because they want the simplest form. So a, 5x minus 6, that whole thing, so I'm going to put it in parentheses, is being subtracted by b, which is 2x plus 7. So I'm putting it in parentheses to show it's not just minusing 2x, it's minusing all of it. So I need to put it in parentheses to show that it's minusing all of it. And we've been talking about when I see a minus like this, I need to distribute it to both. It's like a negative 1. So when I multiply it times the 2, I get a negative 2x. So I write minus 2x. And when I multiply it times a plus 7, I'm going to get a negative 7. So I'm minusing 7. 5x minus 6 basically just comes down, because there was nothing out here to multiply by. There's really a 1. And if you multiply it by 1, nothing changes. So here's my expression. I need to simplify. So 5x minus 2x is 3x. And then minus 6 and minus 7, or negative 6 and negative 7, is negative 13, which I write as minus 13. Okay, so just different style of question, but still doing the same exact thing, testing the skills that you've got. But can you now dissect a question that's asked just a little differently? Good skills to have. All right, so moving on now to our geometric shapes. You have looked at perimeter and area in your past studies. Perimeter is the sum, which is adding all the sides of a shape, the distance around. If you want to put a fence around the perimeter of your property, it goes around the outside. We don't care how much space is on the inside. That's something else. Perimeter is just distance around the outside, where the fence would actually be. So this says write and simplify an expression for the perimeter. If it said area, we'd do something different. So it's important that we recognize it says perimeter of the triangles and the rectangles given right here. So let's pretend for a second these actually had numbers instead of expressions. If these were all 10, 10, and 10, and I said, what's the perimeter? Hopefully you would say 30, because you added 10 plus 10 plus 10. Okay, but in this case, they're not tens, they're expressions. But what did I do with the tens? I added. I said, this 10 plus this 10 plus this 10 equals 30. So since they're just expressions, I can't get a numerical answer like 30, but I can write an expression that represents it, and I can simplify, and that's what they want me to do. So it's this plus this plus this. And it doesn't matter which one you put first. You could say this one plus this one plus this one. Any order, when you add, the order that you add them in doesn't matter. So I'm just going to start with the 3x. If I was finding perimeter, I would take whatever this value is, and I would add it to one of these two values. So I'm going to say plus 2x plus 5. And I'm going to put it in parentheses just so I can see, okay, this is term 1, this is term 2, plus perimeter, you got to add up all the sides. It's distance all the way around the outside. So right now I haven't added the 5x minus 4. This is an expression representing the perimeter, but I need to simplify. Okay, so I'm going to combine everything that I can. There's no minus signs here, so I don't need to distribute anything. There's really ones. So if I did distribute, nothing changes. So I can start putting things together that match. 3x, 2x, and 5x. That's a total of 10x. And now I have a plus 5 and a minus 4. Plus 5 and minus 4 gives me positive 1. So I write plus 1. So why is this useful? So let's say we knew that this was a shape that we wanted to actually find the numerical perimeter of. And I told you now that x was equal to 4. You could plug it in here, figure out that 3 times 4 is 12. You could plug it in here, figure it out, plug it in here, figure it out, and add them all up. But once we have this expression, if we want to know the perimeter, we could just plug the 4 in here. 4 times 10 plus 1, and I'm done, instead of doing all this extra work. Okay, so this is a much more useful expression. Quickly finds me the perimeter of this shape. Even if I enlarge it or close it down, depending on how big x is, this will still find me the perimeter. That's why we're doing this. So 23. Here's one where we need to be careful. So very often if I give this question to students and I say find the perimeter of this shape, they're going to add this and they're going to add this and they're going to think that they're done. Here's the problem. All you've done is added this side and this side. Well, that's not the perimeter of the whole shape. The perimeter of the whole shape is all the way around. So you may ask, well, they didn't give me these sides. Well, they didn't write it down, but they did give you those lengths because this side, 4x minus 5, has got to match this side. It's a rectangle. Both sides are equal. So you can put 4x minus 5 right here, and you can put x plus 6 right here. They must match. So now when I want to find the perimeter, I'm adding all of them up. So this one, I'm not even going to write out this long expression. I'm just going to start combining things right now. 4x, x, 4x, x. Well, 4 and 4 is 8, and these are 1s. So 4 and 4 and 1 and 1. That's a total of 10x again. Now you do need to be careful here with your minuses and plus. If I added a minus 5 and a minus 5, that's a total of minus 10. And if I add a 6 and a 6, that's a positive 12. So altogether, that's just going to be a plus 2. So if it helps to write this one out, let's say what that would look like real quick. I would do 4x minus 5 plus, let's put the other one in there, 4x minus 5 plus x plus 6 plus x plus 6. And then you would just combine everything. And you don't need the parentheses in this case. You could just drop the parentheses and start combining everything to get your 10x plus 2. So 24, still finding perimeter, just adding up the outside. So we're just going to write this out. 3x minus 1 plus 6x plus 4x plus 3. Combining like terms, 6 and 3 is 9, plus 4 is 13x. And now you have a minus 1 and a plus 3. So the minus 1 will knock the plus 3 down to a plus 2. And we're done. Okay. Moving down. Right here it says express the sum. So again, adding of the angles. Angles are the measurements in degrees of this space formed between two lines when they meet. That's the angle of this triangle. So every triangle has 3 angles, 3 spots where the lines connect and meet. So we want to express the sum of these, so show that these have been added up 2 different ways. So the easiest way is to just list them being added. Show me what this looks like if you added them. So number 1, x plus 3/2 x plus 1/2 x. Done. This is an expression showing the sum, adding. Now it's not simplified, right? So it wants me to show this in 2 different ways. This is one way. A second way might be to actually simplify. And you might say, oh, geez, there's fractions. Well, 3/2 and 1/2 is pretty easy. They already have common denominators. If I put a 3/2 plus a 1/2, and I add those together, I get 4/2. And 4/2, 4 over 2 is just 2. So when I put these together, I've got 2x, and then I've got this one other x to combine with it. So that is a total of 3x. Let's say I wanted to just come up with a third way. So it needs to be equal to these. It's just another way to write it. So let's just take the 3x and split it. I really could call this 2x plus x. It says the same thing. 2x plus x is the same as 3x, which is also the same as this. So here's 3 different ways to write the sum of the angles as an expression. And we could come up with even more. All right, let's move down. Area now. So area comes in handy when you're working inside your house. So this is not even something that necessarily applies to a career in math. This is something that we were painting the walls in my house last week. And when you go to the store and you're trying to figure out how much paint do I need to buy, instead of just guessing and maybe coming up short or having too much paint, you just measure the walls. So you just measure the base and the height of the wall, and you're multiplying, because we want to find out the area on the inside, the actual part that I'm painting. So I don't care about the perimeter of the wall. I care about the area, the space that I need to cover. So area is the space inside. So it's just the length times the width, the base times the height. So how do I write that here? Write 2 equivalent expressions to represent the area. So area is just multiplying. We're not adding them up. That's perimeter. We're multiplying this length, the base, times this length, the height. So we could go around and relabel. We know that this is going to be equal and be n minus 3. This is also going to be 2. They're going to match up. I'm not multiplying all 4 sides. It's just 1 base times 1 height. So n minus 3 times 2. Now, how do we write that? What does that look like? We're used to writing it like this. This should look familiar. The 2 times the n minus 3. Now you might say, well, you did the height times the base. It's multiplication, right? You can multiply 3 times 5 or switch it around 5 times 3, and you still get the same answer. So you don't have to list the base first times the height. You could switch it around. And in this case, this is a better answer. This is what we're used to seeing. Of course, if you wanted to, you could write it as n minus 3 times 2. These say the same thing, right? And we talked about you could still distribute from this side. So this is perfectly fine. This is just the way we're used to seeing it more often than not, though. So this is what I'm going to go with. Now it says write 2 equivalent expressions. So I already have. These are 2 different expressions that are equivalent. Let's come up with one more. All we need to do now is distribute, right? So 2n minus 2 times 3, 6. So here's one way. Here's a second way to write the same thing. These say the same thing. Here's even a third way. Okay, if we had to come up with another one. All right, last one. Find the missing side length. So first of all, what side is missing? We've got the base. We're missing the height. So we're trying to find the height. And what did they give us? They gave us the area. So how did they get the area? They multiplied the base times the height, the side we're missing. So they multiplied 5 times something, and they got the area. So let's factor this for a second. Go back to yesterday's work and the day before. If I look at 5 and 20, I see a common factor, and it's 5. 5 can be multiplied into both of these. So 5 times what gives me W? 5W. It's just W. 5 times W. And then 5 times something gives me 20. That would be a positive 4. So if I factor this, I see this expression, and that might help me figure out what this height was. So 5 was being multiplied by something to get this. This gives it away. It's W plus 4. Because if I multiplied 5 times W, I get this. And if I multiply 5 times 4, I get this. So working backwards, factoring will help us. Multiplying the base times the height to get the area.